Okay, I would like to draw your attention to these pictures. See? What country is it? European? US? Okay, the Great Depression, right? So this is the United States when people were homeless, hungry, they didn't have jobless, okay, and they were ready for even to sell their children to get food or anything else, right? Okay. We are talking about this Great Depression that happened in 1920s, right? That the banks collapsed, the banking system collapsed, and people were very poor, all right? This is something happened. And again, this thing happened, well, not exactly this, but in 2008, the world financial crisis happened, okay? So, yeah, the world financial crisis happened because of the banking system, because of the mortgage, right? And there were many reasons for that to happen. And the result or the outcome was, again, hunger, no jobs, a lot of bankers made suicides, right? So a lot of people died, left jobless, okay? The topic of our today's lecture is not about depression or crisis. What I want to talk about today is it's about time series data or basics of time series data. We use time series data in order to be able to predict the future, would it be sales or anything, based on the historical data, okay? Using the historical data, you can actually forecast what's going to happen in near future, all right? Now, today we will estimate the change of the value over time and graph dynamics of the value. We'll also learn how to apply the time series analysis to forecasting a value. And the last thing we're going to do is we will be using two methods, additive and multiplicative models, okay? All right, there are four components of time series graph. The first one is the trend. So the trend is something that shows the overall direction of something happening. For example, it can be sales, it can be number of people, it can be electricity consumption, electricity production, or anything. Okay, and then you have seasonality or seasonal variation. Let's say this is the sales of something. Let's say sales of ice cream. Okay, sales of ice cream. The sales of ice cream go up, down, right? This thing, the fluctuation is called seasonality or seasonal variation. Okay, it varies according to the season. For example, during summer it goes up, during winter it goes down, next summer it goes up again. But the overall trend, what's happening here is if we draw a line right between these things, this is called the trend, the overall direction of the data, okay, of where our sales are going. This is trend, and these are, see the differences here? These are seasonal variations, and this thing here is called the actual data, okay, the actual data. And there is a cyclical variation or irregular. So I forgot about irregular. This is something random that happens, you cannot forecast it. Okay, this is something that happens out of nowhere. For example, an earthquake may happen, and let's say it can destroy some power plant, and the electricity production may go down anytime. Okay, or a very severe frost can come to some area, and it can destroy the, let's say, apricot crops. Okay, so instead of having a lot of fruits during summer, you're going to have very few fruits in the bazaars, and the prices will go up. So this is something that is not predicted by humans and not expected. Okay, or anything can happen. For example, let's say the skiing resort in Switzerland, an avalanche can come, and a lot of people may die, and tourists will not go there anymore. Okay, so this is the fall of number of tourists in that area. And another thing is cyclical variation. So it can be above or below the trend line for periods of longer than 1 year. So this is a cycle. So this is exactly what we talked about before, about the Great Depression, about the crisis, or it can also be a good thing. For example, there might be a very good boom of economy, meaning very low unemployment, very good economic health. Everybody has a job, but the employers cannot get the people to work. All right, and that's why they raise the minimum wage. So it can be booming economy. Okay, this is also some kind of a cyclical thing that happens. It can be in 40 years, in 30 years, or it can be in 10 years. So you don't really know. Okay, well, this is not something that happens like in a specific time. Now, this is how it looks. Okay, so this is something that I drew on the board, right? So the blue line is the actual figures. The red line is the trend, and S is the seasonal variations here. These are the seasonal variations. All right, and you have to make sure that you have the time here, and you have to make sure that the times are actually divided into years or the quarters. Quarter 1, quarter 2, 3, 4, etc. Okay, and this is, let's say, year 1, year 2, year 3. And here you have the data. For example, it can be sales, electricity production, electricity consumption, or consumption of gasoline. All right, so many different things. Okay. There are two models, as I said. It's the additive model or multiplicative model. In the additive model, in order to find the actual data, which is y, you add t to s. Okay? T, trend line, plus the seasonal variation. Okay? And in the multiplicative model, instead of adding, you just multiply. All right? Now, can you guys see the difference between additive model and the multiplicative model, the way it looks in the graph? What is the difference? This is additive, and this is multiplicative model. The beginning is bigger, all right? Here. See? What is it?
Over time, the variation starts to increase.
Right. The amplitude or the variation starts to increase in the multiplicative model, right? But in the additive model, it's the same. See, it's the same. It's very stable. The variation is very stable, but it still keeps fluctuating. But this one is, the fluctuation is actually increasing. It's going up and down, like the amplitude is increasing. Now, we're given data here that shows quarterly computer sales over 1, 2, 3, 4, 5 years, starting from 2003 first quarter to 2007 third quarter. Okay, we are asked to find or to forecast computer sales for 2007 quarter 4. Okay. So let's assume now it's 2007, quarter 3 has ended, and you have this information. Now you need to forecast your sales for the next quarter. How much will it be in 2007 next quarter? All right? So here you have the sales. The first thing you have here is the time. And the next thing is sales. Or you also can call it Y, right? Okay. We have 2003, quarter 1, quarter 2, quarter 3, quarter 4. Done with this one. And 2004. 2004, 1, 2, 3, and 4, as you can see. All right? 2005, 1, 2, 3, and 4. Okay, here we go. Okay, now what we need to do is, well, we have 2 more years, right? So it's 2006 and 2007. I don't know if we can fit it in here, but okay. Well, let's write down the sales. So the first 113.5 and 132.9. Okay? And so on. So now we're doing the additive model. Okay? So the first thing you need to do is you need to find the 4-point moving average. So we call it 4-point moving average. All right, so this is 4-point moving average. Now, in order to find the 4-point moving average, what you need to do is, so I will just erase these lines because they will, okay, here. All right, here. So 4-point moving average is calculated taking the first 4 numbers and finding the average of these 4 numbers. And you should write it in between these 4 numbers, which is between the second and the third number. That's going to be right here. Okay? So can you guys calculate the average of these 4 numbers? What is the average of these 4 numbers? Oops. Yeah, let me see, actually. Okay. Okay, 95.58, right? 95.58. Okay.
I have a question. When there's 5 here, do we take 58 or do we take 57?
Yeah, so if you have 5 or more, you round it up. If it's more than 5, it's rounded down, right? So 95.58, right? So 95.58. Now we took the average of these 4 numbers. Now the next 4-point moving average would be starting from the second. 1, 2, 3, 4. Now you take these 4 numbers, okay? So these 4 numbers, and you write it in between these, okay? Right here. So what is the average of these next 4 numbers? So you move 1 step down and calculate 4-point moving average. So, well, actually I can use my own phone. Okay.
100.38.
Okay. 100.38. And the next one. Now you take next 4. So starting from the third number. 1, 2, 3, 4. So let me actually use another marker here. So we're going to take starting from 94.2, until 102.4. So what is the average of these four numbers? Okay, 100.25. Okay, and then we take the next four, which is starting from the fourth one, right? So this, and we write it here. Okay, 104.48, right? So 104.48. Good. So I'll go ahead and, yeah, okay, so 104.48, 106.65. So here, 106.65. That's going to be in here, right, between this and here, between this. Okay, so you have to make sure that the numbers are in their own places, okay? So 106.65, then you have 108.60, right? 108.60, 110, 112.60, 112.60. Then you have 118, oh, I'm sorry. Okay, 117.0, so 117.03, and 120.18. Okay? So here we have calculated, so here we have 2006, 1, 2, etc., and 2007, okay, etc. Okay, so the it's not enough here. I mean, the space is not enough. So what we're doing is, so we have calculated 4-point moving average. So this is how you calculate it. Now the next step would be to calculate the CMA, or centered moving average. Okay, and centered moving average, by calculating centered moving average, you actually find the trend line. This is called trend T, and this is the actual. Say actual sales, and this is centered moving average, or trend, right? T, and this is Y. All right. How do we find trend? Now pay attention. So what you have to do is, now instead of taking 4, you just take two numbers, two first numbers. So you take 95.58 plus 138 and divide it by 2, and you find the average of these two numbers. And for the first one, it's going to be 97.98. Did you guys get the same number? Right? Okay. So you see? And now, pay attention. A very important thing here is you should know what quarter of which year it goes to. This number goes to here. You see? So it's 2003, quarter 3. All right? And the next one should go between this, and it goes to 2003, quarter 4. All right? And I will just copy the numbers that were calculated earlier. That is 101.31. The next one is 103.37. And 105.57. 105.57. 107.63. 107.57. 103, 105. Then you have 107. I'm sorry. 107.63, right? That's 63. Well, anyways, okay. So, I mean, you have the numbers here. All right, so you have the numbers here. So once we calculate the centered moving average, what we do is we try to plot this actual data in the, so we are plotting the actual data, so we have to make sure that your graph looks nice and neat. Okay, here. So what you have to do is you have to make sure that all the years are included. All the years are included. You have all the, that's 2003, 4, 5, 6, and 7. Okay? 3, 4, 5, 6, and 7. All right, and I have to quarter 1, quarter 2, quarter 3, and quarter 4. Same thing here, quarter 1, quarter 2, 4, and etc. Okay, so plotting the CMA, or centered moving average. So this is the trend line. So trend line is the general picture or direction that shows where our data is going to. Is it going up, down, or if it's going up, like where? Okay? So if you remember last lecture, we talked about the trend line using the regression. You remember the regression line? And we found the B, which was calculated using the least squares method. Okay? And there was a big formula that was very hard to derive. So in this case, we are using just a trend line, and we're just drawing it visually. And for, let's say this is 50, this is 100, this is 150. That's 50, 100, 150. Okay? Now, plotting the first point, 97, 98. Where does it go to? This is sales. Sales. So sales 97, 98. Where does it go to? So you look at here, and it says it's 2003, the third quarter. So our first point will start from 2003, the third quarter. So it should come from here. 97, 98, it should be somewhere here, right? Just visually, it's going to look like this. And the next one is 101.31. So it's the next quarter. Okay? That's 103. Okay, so it's somewhere here. And then you're going to have something like this, right? So you're going to have a trend line more or less straight. Okay? So what you do is, once you plot these points, your last point will stop here. You see the black line? The black line? So where does it stop? It stops right in here. 2007, quarter 1. Okay? Quarter 1. So So 2007, let's say quarter 1 is right here. Right here. So 2007, quarter 1 is right here. But what year or what quarter should we forecast our sales for? So what we have is we have all the data until quarter 3, 2007. You see? We have all the numbers until 2007, quarter 3. But we don't have quarter 4. Okay? So we need to forecast for quarter 4. So what you do is you basically stretch the line visually. All right? So it's very just like this. Just stretch it. Okay? This is not something very precise. And you find what this trend line is for, let's say, quarter 4. Okay? So you just find it visually. There are no calculations, nothing, no formula for this. All right? So just visually. So if you do it on your notebooks, everybody is going to get different numbers. Okay? This is a very, I would say, childish way of doing that, but this is what you have to do so far. Okay? So, and if you do this, I mean, you see, I am getting more than 150 because my scaling was a little bit different. But what they're getting is 142. Okay? It's very approximate. This is not something that we came up doing some mathematical operations. Okay? If you do the regression line, everybody is going to get the same number. Okay? The regression line will tell you the exact value for this. Now, this is 142, let's say. 142. Okay? Now, let's remember this. Now, the next step would be to find deviations from mean. All right? So I'm going to go ahead and show it using deviations from the trend. So CMA is the trend line, right? So we use these numbers to come up with this trend line, right? Now, this is a trend line. Now, what is the deviation? Deviation is how far is the actual data from the trend or the mean, the trend line, okay? Now, to do that in additive model, what we do is we basically subtract, right? We basically subtract. So deviations from mean is equal to y minus t at x time, okay? We basically subtract. So what we're doing is, let's say this is our actual data. What we're doing is we are finding this distances, okay? So we do it for each and every observation we have. Let's say I'm going to erase this part. So your next column would be deviations from trends. Let's say deviation from trends. So let's look at the slide. To find S, what they're doing is, so what was the first number for trend? This is this, right? 97.98. So to find the deviation from trend, what you do is you subtract this from the actual sales, T from Y. So 94.2 minus 97.98. You see? And you're getting negative 3.8. All right? And the next one is 106.5 minus 101.31. That's going to be 5.2. Okay? And etc. 2.5, negative 3.2, etc. Okay? So you subtract everything one by one. Okay? So this is the next step. Now, to calculate the real seasonal deviation, so these are actually deviations from trend. To calculate the seasonal deviation, you need to come up with another table, which is called the seasonal deviation table, seasonal variation table. Okay? And we'll have to draw a table like this, where we have Now, I want you guys to understand this and pay attention to this one. So it's, you write the years on the first column, so all the years that you have, 2003, 2004, 2005, 2006, and 2007, right? So all the years. Now we have the quarters. That's going to be quarter 1, quarter 2, 3, and 4. Okay? All right. 1, 2, 3, 4. Now, what cell do we start from? So to find that, we look back to our previous table, and we'll see that our first deviation from trend starts from what? The third quarter, 2003, right? So what we do is we just copy these numbers into this table. So that's going to be 2003 third quarter. That's negative 3.8. And the next one is 5.2. And the next one is 2004 first quarter. This one. That's what? 2.5, negative 3.2, negative 4.5, 5.9, etc. Right? So I'll just copy from here. So 2.4 here. Then you have negative 6.8, negative 5.1, 11.3, 1.4, negative 8.7, negative 1.6, and 9.9 here. And the last one you're going to have is 3.7. You see, so although you had data for this years, for these quarters, when you calculated the 4-point moving average and centroid moving average, we end up with having the last number for 2007, the first quarter. Okay, so now the most interesting part, or I would say important part, starts here. So what you do is you calculate the total number. Okay, so you calculate the total. And then you calculate the average deviation. Average deviation. So the total would be just total of the sum of all these numbers, right? So here we have, okay, 9.7, negative 18.7, negative 15.0, and 32.3. Now the average deviation is the average of these numbers, meaning the total divided by the number of observations in each year, for example, in each quarter. So how many observations do we have in quarter 1? How many? No, how many observations in quarter 1? 4, right? 1, 2, 3, 4. So you basically divide this number by 4. Okay, 9.7 divided by 4, you get 243. And here you divide by 3. Yeah, so it's negative 6.23, negative 3.75, and 8.08. Okay? And then you have the adjustment. Okay? So adjustment means you take the average of these 4 averages. Okay? So 1, 2, 3, 4. You add them up and divide by 4. And you got the adjustment should be the same number for all. So 0.13, 0.13, 0.13, and 0.13. Okay? And the last thing you need is the seasonal variation. So we were actually trying to find seasonal variation, and here it is. Seasonal variation, or SV, right? So to find the seasonal variation in the additive model, so what you do is you subtract adjustment from average deviation, or average deviation minus adjustment. Okay? 2.43 minus 0.13 will give you 2.3, right? Negative 6.23 minus 0.13 will give you negative 6.36, etc., right? So negative 388, negative 388, and 7.95. 7.95. All right? Now, we have found the seasonal variations. What was the first question they asked us to find? And what was the task? The task was to forecast the sales for 2007, the fourth quarter. Okay? The fourth quarter. Now, our formula to find this was what? So the actual data. So Y 7 fourth quarter is equal to trend of that year, let's say 2007 first quarter, plus the seasonal variation of this year, 2007, the fourth quarter. Okay? Now, what do we have? What is the trend? What is the trend we found? By stretching the line, the trend line. 142, right? So 142 plus, what do we add? Which one? This one, right? Why? Because this is the seasonal variation for the fourth quarter, right? So this plus 7.95, you're going to get 149.95, right? So now you can say that in the fourth quarter of 2007, our sales, or your sales, will be equal to almost 150. See, it says in thousands, 150,000 computers. Okay, and to find that, you just right. Okay, so this is the last step you do. So that this is your forecast. Okay, using the additive model. All right? Okay. We are done with additive model. If you have any questions in any step, please ask now. Any questions? So, what were the steps? The first step was it was the first table. So the first step was to calculate 4-point moving average. Then we calculated the centered moving average, right? And then we calculated what? Deviation from trend. And then, using deviations from trend, we created a new table. And we found the seasonal variation. And what is important here, in additive model, to find the deviation from trend, we subtract. To find the seasonal variation, we again subtract. From average, the adjustment, okay? That's it. And we actually used the stretching method to find the trends for 2007 fourth quarter. Now I would like to draw your attention to the next method, which is the multiplicative method model, right? Which is completely, the same. Okay, it's the same. You use the 4-point moving average. You find the 4-point moving average the same way. You find the CMA the same way. And to find the deviation from trend, instead of subtracting, you divide. Okay, so this is, you remember, these are the same numbers. All right, here. To find the deviation from trend, you divide y by t, or the actual number, the actual data by the trend. Okay, and you get these deviations from trend. All right? They are all close to 1, and none of them are negative. Okay? And the next step would be you put these numbers into this table. Again, you put these numbers into the seasonal variation table, just like this, and find the total number, find the average deviation, find the adjustment by finding the average of averages. And to find the seasonal variation, instead of subtracting, what you do is you divide average deviation by adjustment. Okay, you divide, not subtract, but divide. So 102 divided by 1 is 102. Okay, so it's the same number. So now you have the seasonal variations. Now, can you tell me the forecast for 2007 fourth quarter? What will be the sales for fourth quarter? So what do? What is it?
It goes up.
Yeah, it goes up. How do you know?
It's more than 1.
Right, exactly. So the seasonal variation is more than 1. So now to find the seasonal variation, to find the actual data using the multiplicative model, so what you do is, again, so to find the actual data for 2007 quarter 4, using the multiplicative model, we do trend of 2007 quarter 4, now multiplied by seasonal variation of 2007 quarter 4, okay? Now, to do this, okay, so we are calculating it here. So our trend was, again, 142 multiplied by 107, right? 107. And the answer would be, okay, 151.19? 94. 94, right? Okay. Well, yeah, okay, so 151.94, which is almost equal to 152. Okay, so you got a little bit larger number than the previous one, just because you used a different model. Okay? That's it. So 2 models. Now, today you learned how to show time series graphically, how to analyze time series, how to use 2 models to find or to forecast the future data using additive or multiplicative model, and you know which model to use looking at the graph, right? So if the amplitude of the variation is increasing, then you better use which one? Multiplicative, or if it's the same, you better use the additive model. Okay.